nice and tight on my face today, and I like that. I like that. What's going on, James, and what's going on everyone else watching this video? If you missed the first two videos in the series, don't watch the first one, it's terrible. But if you missed the first two parts of these series, these are my videos to James Hobson, aka the Hacksmith, letting him know, or explaining the design I'm building for him, right? And then for you guys, it's kind of sneak behind the scenes, see a little bit more detail. For James, he hired me to make this. This is me explaining the design to him. Easier just to make a video and show it to him. Today I'm showing the pelvis, which is like the lower part. It's like this part, that part in there on the suit, and it also has two out of three axes of the hip joint on it as well. But before we start with that, I have a surprise for you, James, because I think this is awesome. I figured this out last night, and I was working late into the night, and I did something pretty cool. Waiting on it to load. There we go. All right, so this is the surprise. I'm gonna keep these mostly to the pelvis file because I don't want anyone to see the entire suit until we present it on your channel, James. But I just gotta show you this because this is really cool. This is the torso, you remember from last time. Here it is. Here's me inside of it. This part right here is new. This is what I call the power pack, and this thing's awesome. So it's gonna be I think 7/16 bolts, not quite half-inch bolts, but big old bolts, attaching the back side of the torso, and then it's gonna have some just stainless steel tubes that can be lathed up and then just bolt on. And then the piece that I have on here right now, this piece right here, this is just like a cool shape I put on there. But what's cool about this is that we can laser up any pattern we want. We can literally make it fit your entire backside of your body, like from the tip of your head all the way down to the bottom of the pelvis. And then we can just cover it with holes, and then it's like essentially a fixture plate that we can pack on all kinds of batteries and hydraulic systems and air compression systems and electrical systems and computers, and put the entire thing just right on this thing. It adds a lot of structural powered, like it makes the back of the torso more structural too, because there's two parts. And it's just, I mean, you could literally hang Bogdan by the end of this thing and just hold it on. He can hold on to the back of it. It's gonna be really cool. So that was just a little surprise. I wanted to show you that, but that's not what we're focused on today. What we're focused on today is this thing right here. So this is the pelvis. So first, what I want to do is I want to give you a back view. This is my 3D scan in here, but obviously it's been rescaled to fit you, James. That's the back view. Here is a side view of it right here, and there is a front view right there. So now I want to show you how to take it on and off. So let me show you that real quick. So I'm going to turn off some of these components, and I'm going to show you. So this right here would be the back part you would sit into, and then so you'd step into this, and this would go up the entire back of the suit, and then you'd step and sit into this part right here, and then this front piece right here where they come in and bolt on, and it bolts on in these two spots and these two spots. So I'm gonna turn everything back on here, and you're gonna be able to see where those bolts would go and how they go together. So it's 4 bolts in this particular spot. I think I'm missing yeah, there we go. So 2 bolts there and 2 bolts there. These ones are countersunk, these ones are not, but just bolt through, and yeah, that's how that goes together. So that's how it comes on and off. Let me show you how it moves. Now, unfortunately, my motion study kind of broke on me, and it's only spinning over one side, but you're gonna get an idea. I apologize, that should be working, it's just not. These motion studies are terrible on Fusion 360. Sorry to rant for a second, but they're just awful. Okay, so there it is going back and forth. So you see you have 2 axes here, right? So the one at the bottom, that one, this one right here, and then it's gonna go up, and then this one right here like that. So that joint going this way, and then that way like that, that is you're taking your toes and going in and out like this. So if you're rotating your toes in and out like that, that's the ability to do that. And then obviously the up and down one is what they call abduction and adduction. So it's back to that flapping your arms like a bird, but except instead of your arms this time, it's your hips. And then there's one more joint, which is, we'll look on the other side where it's not spinning. This joint right here is where the leg comes down, and comes down this way. And it's where the leg attaches, and this spins this way, and that allows flexion extension of your leg, so it's up and down like you were running. So those are the 3 joints, and you can see these all, and you know, these all spin around the same center point, which is cool. Yeah, it's gonna be really cool. Oh, I did want to show you this. I wanted to show you kind of what's going on inside of here. So okay, so what I want to show you is this in here. This is how, let me turn these off really quick, hold on. Okay, so I have some of the components turned off here. And what I want to show you is how these kind of parts move inside of here. So I thought this would be interesting. You can't really see this when it's all covered up, right? So if it goes like this, there you go. You can kind of see how that slides all the way forward. You can see how this is coming and stopping right there. This is stopping right there, and this is stopping right here. So this piece right in here that moves is an intermediate piece, right? And I have these set up to where they're moving completely in sync with these 2 parts. This might not necessarily happen completely in sync like this. Like, you know, this might slide and hit this, and then this might start sliding and hit this. But this joint works. I've used these type of joints in my suit, and it's just really cool. And I think this gives you a good visualization of how this works. The same thing is happening over here. There's just 2 layers instead of 1 layer, but this is a nice easy way to see how and visualize how that works. The other joint is this joint right here, and you can see here how it's outlined in blue, and that's just pretty easy, right? That's just a hinge joint that moves like that. Those I feel like are pretty intuitive to understand. These guys are just a little bit more complicated, so I wanted to kind of show you the internal working of that, but it's pretty cool. It works pretty good, surprisingly good actually. Better than you might think. It's pretty cool. All right, and then now I want to talk briefly about material choice. I sent you an email about this, James, but I wanted to explain it here as well. Okay, so the next thing I want to talk about is, like, I'm just going to briefly talk about like the manufacturing methods for this, just so we're all on the same page. There's 3 different main ways. The 3 different main ways are laser cutting, which is going to be like all of these pieces in here, all the struts, all the plates, all of this stuff laser cut, right? Maybe even some of this paneling, though you could probably cut that with like a pair of power shears too if you want to save time. I don't know, you can do that a couple different ways. And then there's these perfectly round parts, and these parts should be lathed because they're perfectly round, and then chucked into the mill to drill the holes out. And then parts like this part right here that have this extra geometry, like the one we were looking at earlier, like this part in here, we have like the steps geometry. This is milled, right? So we have milled, lathed, and lasered parts. So what I've done is we're making the main suit out of stainless, which is a good idea. It's a good metal. It's very high tensile strength. It's heavy, of course, but that's okay. And it's very easy to weld and work with. But for the machine parts, in order to save time and just make this all go faster, and they're about the same tensile strength. 6061 and 304L stainless, so 6061 aluminum, 304L stainless. They're about the same tensile strength. I mean, 304L is stronger, but not by a ton. And so I have these parts, all the lathed parts and all the milled parts modeled in aluminum, and this part on this support back here, all modeled in aluminum to make them easier and faster to machine. So I want this to go as quickly and smoothly as possible. There's a lot of parts to machine. I mean, you got a pretty awesome machine shop, so it's not that big of a deal, but if you can make it easier, you can take bigger depths of cut because you're working with a softer metal. That's all great. So that's how I have them modeled right now, and they work in the force simulation. So next thing I want to show you is some simulation stuff here. So this is that hip area we were looking at, and I'm actually showing you the final product. I did quite a few studies, and eventually at first it was having some failures, and I'll show you those too. I'll just show you right now actually. Let's go over. So here you can see how this is deforming a lot through here, and in like here you're actually getting some below 1 safety factor here, so essentially failures and bending here. Now if we drop the deformation scale to actual, you know, you can tell it wasn't moving very much, but I was a little worried about this, you know, because what was happening is at first this part was attached all the way over here, and it was sweeping all the way across. You see there's a gap right there, and it was bending. So what I did is I was able to redesign it, and we'll go back and we'll look at the difference. Right there, now you can see this is like a solid piece here, and it made it very, very strong. The minimum safety factor is a factor of 2, and I'm putting this for a load of 300 pounds, which I don't think we're gonna be able to lift anyway. So that's pretty awesome. This is gonna be very, very strong. Very, very strong. Yeah, pretty cool. Oh, I will show you, this is loading, but one thing I'll say is that the the simulation environment, it has trouble meshing all these complicated shapes together, so I can't really test out the entire suit at once. It throws up a bunch of errors, so I'm having to test pieces of it. So I'm gonna test as many things with this, do as many simulations as I can of different parts of it, but we won't know the entire thing works until we put it together. It's kind of how things work, right? And I just wanted to show briefly, I had some failures in this spot up here on the torso, and I actually redesigned it. I'm trying to find the redesign, but I did some redesign of the torso, and I just wanted to throw that out there really quick. I can't find it, but it's in there somewhere. So I did some redesign of the torso, and that has like a safety factor of 2 now too, at 300 pounds. And maybe I should have talked about this just a little bit earlier, but let's talk about how this thing is actually held to your body. And I'm sure you see these black things in here and are wondering what those are about. So this part sits right on the back, sits on your pelvis, right? It sits on that bone, and the idea is to keep it attached to that bone. The thing is an exoskeleton. That's how I designed it, right? It's power armor, but I designed it as an exoskeleton. So it needs to touch your skeleton and move with your skeleton, not with your soft tissues. So this is like sits on the small of your back and on those bones back there and like the top of your butt. So if I turn me back on, you can see how it's kind of coming through right here. And you're gonna be different size than me, so this may rub a little bit. It may need to be like sanded down to fit you a little bit better. I have a bunch, by the way, I have a bunch of ideas on how to do these soft parts, and I was thinking when we actually start building this, maybe these are something I could build for you. I might need some new tools. I gotta think about it, work on some stuff, but these might be a good thing for me to work on while you guys are doing like the heavy metal stuff. Heavy metal, yeah. And doing that. Then the other things on these are straps. So we have these straps that come through these holes, and then they're just gonna be looped, and then I'm gonna have some lathe parts that stick through it and lock them in there. And it's gonna essentially kind of look like this is kind of what I'm thinking. This is a belt I made. I also have I've done quite a bit of work. This is another reason I might be able to do this for you. I've done quite a bit of work with this is a soft exoskeleton I made that didn't work. But I've done quite a bit of work with this stuff, and I'm actually thinking of trying to include some elastic in it too, but it'll have a buckle, so it unbuckles, and then I'll loop back and have a tri-glide at the end, so it can be adjustable, kind of like a dog collar. And that's how those will work. And then I'm also working on some ways to incorporate some elastic into it, so it has a little bit of sponginess. And these will kind of hold the suit to your legs. The only problem with this is that it may create a reactionary force down here at the bottom, because these are pulling this way, and it may tip the entire exoskeleton this way a little bit. I'm a little bit worried about that, but worst case, we can kind of retroactively add something in, or I might add something before we make the suit, or at least some mounting holes up here in the front to kind of push on the front. But I have some stuff that come in right in here on the corner of your bones, and I might add something like that, but they're pretty uncomfortable in my suit, so it's kind of why I took them off. And I think the straps are probably gonna work better. I'm not sure though, so we may end up doing all three. But these are the straps I have in here right now, and they're pretty cool. I like the way those look. I have some of those I'm working on the torso as well. I just haven't got them into the design yet. All right, James, and then I emailed you and you emailed me, and you asked me a few questions, and I just want to run through them really quick, because I'm sure also some other people watching these videos probably have some similar questions. They're good questions, and I want to address them just briefly here. The first thing you asked about was metal thickness. Yes, we can drop metal thickness. There's a lot of thread tapped holes on the plate, so after it's laser cut, we're gonna have to put some thread taps in there, and also some countersinks in some spots. And you really, for an engineering standard, you really don't want to drop below 4 fully engaged threads as a rule of thumb, and definitely don't drop below 2. You want minimum 2. So all these threads are designed for 32, 1032 taps. 1032 taps. I might could bump that up a little bit too. I'm using a fine thread so that they're easier to tap. You're less likely to break a tap off inside this. So you would have 4 threads engaged with a 32 threads per inch will give you 4 threads engaged in an 1/8 inch plate. So I don't think we should drop below an 1/8 inch plate. Also, there's bearing surfaces in here too. So on this leg here, right here, right, there's a piece that goes in here, and the same thing with this guy in here, right? This is a bearing surface in here. They're hydrodynamic bearings, which means it's just 2 things rubbing on a oil film or something like that. In this case, grease, because it's low RPM and low tolerances, so it's just grease, but it's a hydrodynamic bearing. That's what it is, right? Which actually brings me to your next point. You asked about me using some roller bearings. You mentioned specifically in the sternoclavicular joint, because it's kind of a stacked thing. I don't like, I spent a lot of time thinking about the type of bearings for this, and I came to the conclusion that roller bearings were not a good way to go. Mostly, they're actually not as strong as hydrodynamic bearings, which surprises a lot of people because the roller parts are actually sitting on single points. The load is not very dispersed, and even like the strongest bearings, like ceramic bearings, break fairly easy. They actually, under high loads, and I developed exomuscles. Do I have one up here? I meant to bring one up here. Oh, I need to talk about something. So, okay, so sorry, I had to go get something. But so they tend to break actually under the really high loads of these guys. These are the exomuscles that I made, and these things produce 5 tons of force, and then you put them really close to the axis of rotation, so really close to that bearing, they can actually destroy those bearings. So for that reason, I actually decided not to use roller bearings. The other problem with roller bearings is they require pretty tight tolerances, and because this is welded, everything's moving around and stuff, and the tolerances aren't great. And lastly, it just makes things more complicated now, because then you have to size out all the bearings and you have to make sure your bearings fit. In this case, I can just kind of custom make everything to size and it just fits together. Is that all the reasons? I think that's all the reasons. Because I mean, you could even go in and you could add roller bearings into all of these guys in here, all of these guys in here, all of these guys in here. You can put roller bearings everywhere. Oh, one other reason is that that the load case changes a little bit when roller bearings are spinning really fast. They disperse load better when they're spinning quickly. Their static load is a lot less. And so roller bearings really shine in high RPM situations. And actually, hydrodynamic bearings are usually better for lower RPM situations. You know, roller bearings are really cool and people are like, let's just put them everywhere because they're pretty awesome. They're also like, they don't take hardly any energy to get moving. So the suit might move like a little bit more smoothly if we put them in there, like be a little bit more silky. There'd be less like of a coefficient of static friction would essentially be 0, right? Because they're rolling. I just overall, I don't think for the added design complexity and potentially added weakness, I don't think it's worth it to put roller bearings into this guy. Yeah, that's my thoughts on roller bearings, and it's why I didn't include them to begin with. And also, like, just welding those structures together is gonna be really quick. I mean, you know, you just be able to take them and all tabs together, you weld it out, done. And I kind of want this is, you know, it's a lot to build, so I want it to go quickly for you and smoothly. And you're learning from all of my mistakes too. I've opened up all the tolerances. When I first designed my suit, I had like 10 thou. These all have like 50 to 60 thou tolerance in them now. Yeah, this thing's gonna go together really well, and you're gonna grease it up, and you're not gonna miss the roller bearings, I'm telling you. You asked about linear hydraulic actuators in the across the stomach and across the neck, across the lumbar, and it's a good idea, and it's something I would like to be able to do just because you can buy those off the shelf. The problem is like, let me get into here. And I didn't do a great job of explaining where this force simulation was coming from, but it was coming onto this guy right here, right? So that tube is gonna have a version of this, and I already have the design for it. I haven't built it or tested it yet, but I'm like 90% sure it'll work. It'll have like a tendon coming out, so this is Kevlar, and it'll taper down, and then I'll probably have some kind of metal part on it to keep it tapered, and then run through and essentially become a rope. And then I have some systems for how to tie that off at the end, so it'll come through this hole and through that hole right there, and come down and then tie off at the end. And then it'll attach somewhere up. I'm not entirely sure where these are attaching yet, but they'll run actually through this cavity right here, in between the back plate and the support for the back of your pelvis. It'll run up, and it'll actually probably attach into the torso somewhere, and it'd be nice because it'll actually actuate part of the lumbar as well. There may be some secondary ones that are just across the lumbar and not also on the leg, but most of the muscles in your body move across multiple joints, not just one joint. So this is actually kind of mimicking how biology works a little bit, and it's kind of like double dipping, right? Now we get some actuation across the front of the suit, and then we can balance it, or the back of the suit, and we can balance it in the front of the suit by having it go through here. But if you try to use a linear bearing, and especially you gotta think, it's not gonna there's going to be the lumbar on this, right? So the lumbar, the chance is what's likely going to happen is that it's going to run into the lumbar as it comes across. And I actually realized I haven't put the anchors in the front of the pelvis yet, so I need to add those as well. But I can add all this together as it comes together at the end. I'm giving you kind of the broad strokes right now. But the linear actuators, while I think they'd be a lot easier to work with, I just don't think they're going to fit across the suit. And they might not have enough force either, because like the force is essentially coming down on this, about 300 pounds here, and then, so you have about 300 pounds of force here, and then you have this large moment arm here where the leg is pushing, right? So this is twisting this way. So you need to have a much higher force here to counter out the small force here. And so if it's like 4 to 1 here, which it looks like it's about that much, you're looking at about 12,000 pounds of force that has to be produced around this. That is really easy to do with one of these. Very, very easy to do with one of these. With a small little linear actuator. And I'm a fan of linear actuators. They're really easy to control and you can buy them off the shelf and stuff. I just don't know if you're gonna be able to get those sizes of force either. But the main thing is that this is flexible and it can snake through the suit. I'm feeling pretty confident about this. I have a bunch of redesigns. I mean, it works pretty good how it is, but I have a bunch of redesigns I can do, and I can make this work for you. And I have some ideas on kind of how to hack it a little bit to make it go a little faster, because this is pretty designed out. Some of the power systems for this, not perfect. But I have an idea. I'm not gonna get into it here because it's pretty complicated, but I have some pretty cool ideas that I think can work really good with this. And we have a great place to mount it on the back of the suit now. I think it's gonna be really cool. And I think we can eventually just get them into the arms too. I'm gonna add attachment points for both linear pistons so that you can power it up, and we can make 2 videos if you want. You can do 1 video really quick where we just get something out fast with the hydraulic cylinders, and then we can switch and try to do the exo muscles. A couple different ways we can do it. I'm gonna add attachment points for both. But yeah, it's gonna be, I'm kind of getting excited for that because yeah, this is cool. And then the last thing you asked me was a timeline on when I think I'm gonna be done on this. And I think I can have this the design done in 4 weeks. That's kind of what I'm thinking. Might be a little bit aggressive, but that would put us at May 30th. I've got the 2 most complicated parts of the suit designed. The pelvis and the torso, I think, are the most complicated parts. The torso for sure is the hardest, and then the pelvis is second, I think. At least that's how it was when I designed my suit. So I think I can have this done pretty quickly, so I don't know what your guys' timeline is. You said you were busy, but that's kind of what I'm thinking. The only thing that might slow me down is I suffer from migraines, and I haven't had one in a long time, so I'm overdue with one. But that would probably only knock me out for a couple of days, so I could probably still make the deadline if that were to happen. But yeah, this is really cool. Here's one thing I want to show you. There's one last thing that you might be looking at this and you're like, man, that thing has got a badonkadonk. It's kind of sticking out the back. I mean, you put me in there, you can see it's really kind of sticking out the back. And you may look at that and like, that looks kind of weird. Is that going to look good? Because you know, you want it to look good. It's got to be cool, but you also want it to look good. And I'm not going to show the full body that much because, like I said, I want you to have the big reveal. But I'm just going to show you for a second. All right, just a second here. You can see with the torso that it looks right. It doesn't look weirdly bulky. You have the bulk is all in the back, but it's uniform all the way across. So I just wanted to show you that in case you were like, what's going on with that, Dylan? Yeah, so that's what's going on. That's what's going on, James. It's pretty cool. I'm pretty excited. I'm seeing some parts come together on it that I'm like, oh man, this is gonna be good. This is gonna be a good suit. And it's so much better than the one I designed. Like, it's so much better than the one I made for myself. I've learned so much from working on the one I'm designing. This is so much more smartly designed. It's gonna be so much less janky than mine. It's gonna be so much easier to put on and off. It's gonna be so much stronger. It's gonna be powered. Mine is like quasi super, kind of ready to be powered, but not really. So, all right, I'm rambling. James, I hope you're excited for this. I am. I'll talk to you soon. Hopefully we'll be getting both the neck and the lumbar to you next week. And yeah, man, let me know if you have any questions or feedback for me and just what you're thinking. Bye, guys. Record so that we can use the talking to the camera.